Okay, so this will be a quick lesson because we're really just putting everything together that we've learned all week. So when looking at f of x equals x minus 1 all over x squared plus 4x plus 3, the best thing to do first is factor it, just so you're ready to look at it and see your domain, your vertical asymptotes, x-intercepts, all that stuff, just from looking at it. So the first thing you want to do is just factor it if possible. So the numerator, there's nothing you can factor, but the denominator is a quadratic. So your two factors of 3 that add up to 4, x plus 3 and x plus 1. This is just going to make listing out the characteristics a little bit easier. So a few things we can do, we can start with is by finding and listing our horizontal and vertical asymptotes. Our horizontal asymptote is going to help us with end behavior. Vertical asymptote is going to help us with domain. So if you think about what we learned yesterday, your horizontal asymptote is the ratio of your coefficients if the degrees match. Currently they don't match because you have a degree 1 over a degree 2, but we can add in a 0x squared without changing the problem, right? So now we look at the ratio of our leading coefficients, which is 0 over 1, and 0 divided by 1 is 0. And then our vertical asymptotes, remember, comes from where our denominators are, our denominator equals 0. So think about, what do we get when we set x plus 3 equal to 0 and x plus 1 equal to 0? We get the vertical line, -3, and then -1, okay? From your horizontal asymptote, it's going to tell you your end behavior, right? So our end behavior, as x approaches negative infinity, f of x will approach 0. As x approaches positive infinity, f of x will also approach 0. Your vertical asymptotes are going to help you list your domain. And because those are your restrictions. So what it means is that all numbers work until you get to -3. And at -3, you don't have an output. So that's why you have to show that break. And then all the numbers between -3 and 1 work, -1. And then from -1 to infinity. So notice how we got all that information without even looking at our graph, okay? The other thing we can get without looking at our graph are x-intercepts and y-intercepts. Your x-intercept comes from setting your numerator equal to 0. So if I set x minus 1 equal to 0, that leaves me with 1. And my y-intercept, remember, is your ratio of your constants at the end. Because if we plug in 0 for all the x's, what you'll be left with is -1 over 3. Okay, so again, we have gotten everything, all of this, without even looking at our graph. So at this time, I want you to graph this function in Desmos or your graphing calculator. I would suggest Desmos because it's going to be easier to tap on the graph or move it around if needed. When you go to do that, remember, you want to, especially if you're in your graphing calculator, you'll need to put the numerator in parentheses and your denominator. And I would say just put it the way it's written, okay? Because let's say you made a mistake with factoring, you would catch your mistake if you put it in the way it's written. If you put in your factored form into your graphing calculator and you factored incorrectly, you wouldn't catch your mistake. So this way, it's kind of like a checking tool. Okay, when I plug this in, do I have a vertical asymptote at -3 and -1? Yes. Do I have a horizontal at 0? Do I have an x-intercept at 1? Do I have a y-intercept at 0, -1/3? So just, it's better to put in the original because then you'll be more likely to catch your mistake if you did anything wrong. So you want to make sure when you start to graph that you graph those vertical asymptotes with a dotted line, and you can label it underneath. We have our y-intercept of 0, negative 1/3. I have my x-intercept of 1, 0. And I think those are the only points right now that we know. Learning about the, we need to put in our horizontal asymptote as well, y equals 0. Okay, so kind of picture this like you have 3 lanes, right? You have a lane right here, you have a lane right here, and then you have this lane. You need to have points in all those lanes. If you don't, you may need to plot additional points, okay? So notice in the far lane, I actually have 2 points. I have enough information to plot this, okay? I know what this is going to look like because I've learned about the patterns of what a rational function looks like. I know that as it gets really big, it's going to approach 0, so I know it's not going to go super high over the horizontal asymptote. Now in this middle lane, what you could do is just plot the point at -2. So you could plug in -2 into your equation, or you could tap it on your graph, and you actually have the point -2, 3. And if you were to, that was weird, if you were to look at your graph, you would see it look something like this. Kind of dips a little bit below, but then again approaches those asymptotes. And then you would need one more point on the left to kind of know if your graph is up here or down here. So that other point we're going to graph is -4. At -4, you get -1.67. So you're about right here. So that's telling you your graph should be right around here. So when you see where you need to plot additional points, it's more just to get a more accurate graph and to know what's happening in each lane. So it's kind of like picking a point in between your vertical asymptotes or on each side of them. And if you need to plot more, then you plot more, okay? The last thing two things we're going to look at is where is our function positive, where is it negative, okay? So what that's asking for is where is f of x greater than 0? That means where is our curve above the line or above the x-axis? You can see it is right in here, and you can see it right here. So what we would say is between -3 and -1, and then to the right of the x-intercept, which is at 1. And then where is it below? Where is f of x negative? That's from -infinity to -3. And then from -1 until your y or your x-intercept. And then the last piece is where does our function change signs? Notice that down here it's all negative, up here it's all positive, here it's all negative, and then here it's positive. So notice that it's changing sign at your asymptotes and at your x-intercepts or x-intercept. It doesn't always change at your x-intercept, so don't just assume it's going to. And it doesn't always change at your vertical asymptote. So you do have to make sure you take a look at your graph.